My name is Steve Miller. This is my GS-19 or GS-909 capstone. Phoenix High Crimes, exploring the spatial relationship between crimes and dispensaries. This is my study area. So Phoenix, Arizona, is the city limits of Arizona, the capital of Arizona as well. Phoenix is home to about 1.4, 1.6 million people, with the greater metro area reaching around 4.6 million. So getting into the project, the data sources. So most of them, the main one comes from the Phoenix Police Department, provided by the City of Phoenix mapping site. This will be the police grid. So most of these statistics came from 5 years worth of data from November 2018 to April 2023. Other data gathered for this site came from the Phoenix Data Open. This would be dog parks, community swimming pools, sports complex, police stations, just the community entities that were used. Arizona Department of Health provided the dispensary and hospital locations. And then the convenience stores were found using the store locators for both Circle K and Quick Trip, or QT. So here's an example of the Phoenix Police Grid. So the image on the left is the shapefile itself. As you can see, most of the grid is broken up into streets and avenues, mainly generated from north and south and east-west movements. Any irregular shape tended to come from large freeways or large streets that didn't follow the traditional north-south movement, or was broken up by natural terrain such as mountains, rivers, or lakes. And then the image on the left is the classified grid. So it was categorized using the JINX natural break method in ArcGIS Pro. Because of the sensitive nature of crimes, whether it be recency, the ongoing nature, or just the inability to want to put out data of where exactly the crimes were located, I had to use this grid. The grids themselves each have their own number assigned to them, and then a total crime output assigned to them as well. So you can see some of the grids themselves are 0, some range from 1 to 18, up to 78, 200, so on and so forth. So why was Phoenix chosen? Phoenix itself has a high history of crime dating back to the 1960s, and unfortunately that trend continues to this day. Along with crime, it also has a somewhat recent history with changes in its cannabis regulations, and it also differs from federal regulations. In 2010, Proposition 203 was passed, which made cannabis and marijuana medically legal for medical patients. And then 10 years later, Proposition 207 was passed, which made cannabis and marijuana use recreationally legal for adults ages 21 and older. Dispensaries were chosen again because of the recent legal status change. And there are also 41 facilities just within the Phoenix city limits, which would provide good data and a good sample size to use. The problem, crime is always a concern, regardless of cannabis regulations. Some of the previous studies linked to this would be ones out of Colorado and Washington State, as well as the city of Denver. The city of Denver found that neighborhoods that contained dispensaries saw a reduction in crime after the dispensaries were in and up and running. However, the Washington and Colorado study found that counties nearest to the border in non-legalized states, so the neighboring states, saw an increase in crime, presumably people transporting the legal marijuana from that state to the illegal side. So a rise in crime would be found there. There are definitely valid arguments on each side as to whether marijuana will hurt or help these communities. But the goal of this project was to determine if dispensaries were a better or worse indicator at explaining the locations of crime compared to facilities with a lesser stigma. So how we went about creating this? The creation was first find the data. So again, that would be the police crime, the various locations. The next was to classify the crime grid. So again, using the Jinx natural break classification ArcGIS Pro. After that was classified, I had to geolocate and plot the existing variables using the lat and longitude locations. Only those previous community centers, so anything, the dog parks, swimming pools, police stations, etc., those had lat and longitude included. The other locations I had to use Google Sheets and a tool called Geocoding by Awesome Table. I did find this process to be fairly accurate. However, some of the initial locations were not correct, so I had to go into Google Earth and find their actual lat and longitude numbers. Once those were placed, I added a grid column. So this allowed me to go in and assign a grid number to those physical variable locations and plot those together, which then allowed for the creation of the join. And once the join was created, it allowed another field to be made called the join count. So where these grids came together, produced either a 0, a 1, or a 2 in some cases if more than one location was found within that grid. And then the grid count itself was used to run the ordinary least squares or the OLS tool. So the join count was the explanatory variable, with the total crime count being the dependent variable. So here are two examples of the crime grid with overlaid variables. So the image on the left is the crime grid with dispensary locations overlaid upon it, and the image on the right is the crime grid with Circle K's overlaid on it. A little background into the OLS. So what I was really looking for was the adjusted R-squared. So that measured the strength of the model, and it shows the strength of the relationship. The higher the number, the greater the strength. Co-anchor variable assesses the stationarity of the relationship. And then depending on that value, you either use the joint F statistic or the joint Wald statistic to assess the model's statistical significance. The Jacques-Bara assesses the overall bias of the model. If a model was biased, it was believed to be caused by missing information. Then the next table, the coefficient. So this is pretty much the relationship between the explanatory and the dependent variable for graphing purposes. A positive coefficient would mean an increase in crime, and the number of dependent variables would also increase. And then to the far right, we were using probability. Again, this would test the model's statistical significance. So essentially, we are using the statistical values to determine the strength of the relationship between dispensaries and crime, and see if any other factors have a stronger or weaker relationship than that. So into the OLS, this is the dispensary information. The first table is the standard deviation and the residual count. So as you can see, the light blue and gray areas was an underprediction of crime. This could probably be caused by the initial 0 crimes reported earlier in some of those squares. But it does have areas of high underprediction, so that would be the dark red. Moving down to the, Then the data itself, we'd like to see a bell curve produced from it, but it tended, as you can kind of see, it's skewed to the right, just with all the heavier information being located in that light blue or the yellow, and then tailing off to the right. So the adjusted R-squared was 0.0127, meaning crime placements were described by dispensaries at a 1.27%, so not that high. It's a very weak relationship. The crime itself was found to be clustered, not random. And then the model was biased, so there was some missing information according to the model. But both the joint F and the probability found the model to be statistically significant. So dispensaries were the main goal, testing those out, but this wasn't the highest indicator of crime. That would be the Circle K results. So again, high areas of underprediction, and then a good medium amount there, but in the yellow, with the pretty much same level of underprediction of crime. But this time the adjusted R-squared was 0.0508, meaning it covered 5% of the crimes. Again, this model also had bias, but was proven to be statistically significant. So what conclusions can we be made between crimes and dispensaries? There is a very weak yet positive relationship found. It is statistically significant, yet the model also contained heteroscedasticity, meaning the standard deviation residuals did not create a random spread throughout the graph. And the model was also biased. So again, according to the OLS results, it was missing some information. And in general, QTs and Circle Ks, so both convenience stores, produced a stronger relationship between crimes than dispensaries did. Not surprising. Police stations produce a negative relationship, so crime really doesn't like those areas. What can be done in the future? I would say more studies with potential for pinpoint locations could help find strong relationships. Another way would be to find more distinct categories of crime, so maybe categorizing by specific violent crimes or specific non-violent crimes. You could also add more demographic information to help boost the adjusted R-squares. But overall, although statistically significant, dispensary locations produced a weak relationship for explaining crime in locations for Phoenix, Arizona. A little short and sweet, sorry about that, but this has been my presentation, and thank you for your time. Are there any questions?